We'll solve May, June 24, paper 2, variant 3. It's a MCQs paper and 40 marks. So you have 45 minutes to solve this paper. So let's start. Question number 1. A student measures the volume of a small irregular shaped stone. So small and irregular shaped stone like that. So you want to measure its volume. So certainly we only need a measuring cylinder partially filled with water. Option will be B. So measuring cylinder containing some water can help you to find volume of irregular cylinder stone. Which quantity is a vector quantity? You know vectors have magnitude and direction. Electric field strength, yes, it is a vector quantity. All field strengths are vector quantity. Electric field strength is direction is away from positive charge and towards negative charge. Energy, mass, and temperature, they are scalar quantities. Option is A, my dear students. Question number 3, an athlete runs 2.4 kilometer distance in 12 minutes. What is the average speed? If you look at all options, they are meters per second. They are all meters per second. So your first task is to change kilometer into meters. You multiply this by 1,000. The distance comes to be 2,400 meters. Minutes, you multiply by 60 to change minutes into seconds. We multiply by 60. So the time is 12 multiplied by 60, 720 seconds. Average speed is total distance divided by total time, 2,400 over 720. The answer is 3.333. Option B. Makes sense. Question number 4. The graph shows how the speed of a car changes during the period of 50 seconds. Which row of the car gives greatest acceleration and greatest deceleration? Whether it's a greatest acceleration or greatest deceleration, the gradient should be maximum. There is no other way. The acceleration is only in the section 1. So question is you need the magnitude, means values. So acceleration will be this gradient, which is 20 divided by 15, which is approximately 1.3. The acceleration. This part was acceleration. Deceleration are 2 sections. One is D1, other is D2. If you notice, D2 is more steeper. So steeper means more magnitude. So go for this one. Here, the change in y-axis is 15 minus 0. Change in x-axis is 50 minus 45, which is 15 over 5, which is 3. Deceleration is 3. The right option is D. Question number 5. Which statement about the gravitational field strength G is correct? We know that W is the weight, which is M multiplied by G. G is gravitational field strength, which will be weight divided by mass. Option A says G is mass divided by weight. It is opposite. Option B says G is mass multiplied by weight. No, it's weight divided by mass. G is defined as mass per unit force. No, it is actually force per unit mass. G is acceleration of free fall. Yes, G is acceleration of free fall, which is taken as 9.81 on the surface of Earth. Question number 6. Which property of object cannot be changed by applying force? Only thing which cannot be changed by force is the mass. Option is A. Mass cannot be changed by applying force. Question number 7. A small ball of mass 10 kilogram travels horizontally at speed 600. It strikes the wooden block of mass 1.9, which is stationary. So means you have M1, the ball, you have U1, its speed, you have stationary U2, 0, you have mass of the wooden M2. The ball stays in the block. This means they join together. They join together. If two particles after collision, they join together, it means they move together, their velocities are same. So they move with same velocities. The momentum rule is principle of conservation of momentum says total momentum before collision is total momentum after collision. Before collision, we say M1 U1 plus M2 U2. After collision, M1 V1 plus M2 V2. Before collision, the data I'll substitute M1 0.1, U1 600, M2 1.9, U2 0, M1, okay. Since they move together, you can write after collision, it will be M1 plus M2 into V, since they move together. So 0.1 plus 1.9 into V. The left-hand side is 60 plus 0, 60. The right-hand side is 2V. If you solve this, 60 divided by 2, answer is 30. We applied the principle of conservation of momentum. Total momentum before collision is equals to total momentum after collision. Question number 8. Question number 8 says, an object is taken underwater will be damaged if total pressure acting on it is greater than 2.1 MPa. This M is the capital M, which means mega. Mega is 1 million or 10 to the power 6 pascals. So if the pressure exceeds more than 2.1 megapascal, the underwater object will be considered to be damaged. What is the maximum depth? Depth means H, you want to find. P, you have. Okay, the problem is, they say the object can be taken before it breaks. Atmospheric pressure is this. Let's understand. So here, underwater, this is the water surface. The atmospheric pressure acting is 101,000 pascals. The total pressure is 2.1 mega, 2.1 into 10 power 6. So it means how much is the liquid pressure? Liquid pressure will be the difference, 2.1 into 10 power 6 minus 101,000. If we subtract them, it gets you the liquid pressure. So 2.1 times 10 power 6 minus 101,000. This is the liquid pressure. Question is what? The question, now there's another 0. Now the question is, you need to find the depth. Liquid pressure, which you just found, we know the formula of liquid pressure is rho g h. You need h. It will be pressure divided by density times g. You substitute. Pressure is 1,999,000 divided by density, they gave you 1000. G, 9.81. Calculate this. So 1,999,000 divided by 1000 times 9.81. 203.7 meters. The only option is B. That was a good question. Question number 9. A piece of solid metal melts to become liquid. Metal is melting to become liquid. How do the particles of metal or their behavior change during the process of melting? They increase the size. Size of the particles never increase, no matter what. They move around each other, yes. When it was solid, they could only vibrate. Change into liquid, now they can move around. So option B is right. We don't have to read any other option. Melting will cause the solid to change into liquid, and liquid molecules, they can move around. They can move, slide past each other, my dear students. Question number 10. Brownian motion of particles is observed. Which statement describes the movement of the particles? Brownian motion. 1. Particles all travel along the curved paths. No, their paths are straight until they're hit by something else. 1 is wrong. Anything with 1 you can cross. Particles move randomly is true. The particles all travel in same direction. No, randomly their direction keeps changing. Their directions keep changing. 3 is also wrong. So correct option is only D. Question number 11. A fixed mass of air in a cylinder is compressed by a piston so that the volume of the air decreases at constant temperature. This is a very important thing you have to keep in your mind. The temperature constant means neither the kinetic energy of the molecules will change, nor the speed of the molecules will change. Speed or kinetic energy only changes if the temperature changes. So keep this point in your mind. How do their air particles now collide with? So speeds are same, but since volume is less, and compressed mean pressure is more. So more pressure means the particles will collide more often, but the speeds will be same. Greater speed, no. Greater speed, no. You shortlisted 2 options, either B or D. Now, since pressure is more, so they collide more often, but the speed remains same. The diagram shows a quantity of a gas trapped in a cylinder. The piston is pushed in as slowly and gas is compressed. Again, it's quite similar to the previous. So when you are pushing, the gas is compressed. So you are increasing the pressure. Gas is compressed. The volume is decreasing. Boyle's law says that the pressure of a gas is inversely proportional to volume. If 2 quantities are inversely proportional, their graph of those 2 is a curve, asymptotic to both x-axis and y-axis. The option is B. Question number 13. The liquid level in thermometer rises when the thermometer is placed in hot water. So you place in hot water, the liquid level rises. So it means what? Liquid rises because liquid expands. Thermal expansion causes the liquid to expand, so that's why the level will rise. Option is C. Question number 14. Which statement describes what happens as ice at zero becomes water? This means ice is melting. Ice is melting. So melting requires thermal energy. You can't melt anything without thermal energy. This thermal energy will be absorbed and used to overcome the intermolecular forces, weaken the bonds. Energy is absorbed and the temperature remains constant. Whether it's a melting, boiling, freezing, or condensation, in all cases, the temperature has to remain constant. Question number 15. Which row explains how increasing the surface area of a fixed volume of a liquid water and blowing the air over speeds up evaporation? Without looking at the options, if you increase the surface area, the rate of evaporation will increase. Number 2, if you blow the wind, mean there is more wind, more air, rate of evaporation will also increase. In both cases, the rate of evaporation will increase. So increases, wait. So increasing the surface area increases the total number of water molecules present? No. It causes the total number of water molecules to leave the surface. Leave the surface. So more numbers on the surface. So this is not the surface. Increases the top, again present? No. Increases the number of water molecules closer to surface? Yes. Increases the molecules closer to surface? Yes. Now, blowing the wind. Blowing the wind will reduce humidity. It will blow away water particles. It reduces humidity. So now let's read C. Increases the energy? No. Kinetic energy only increases if you increase the temperature. Removes the water molecules from above the surface? Yes. This means actually it reduces humidity. Option D. Question number 16. Question number 16 says, the table shows the state of materials P, Q, R, S, and whether each one contains free electrons or no. So they are telling you the gas, first of all, P, material P, they are saying it is gas, no electrons. Q, it is liquid, no electrons free. R, it is solid, free electrons. And S is also solid but no free electrons. Using the information, which comparison of thermal conduction in the materials is correct? It is better conduction. First of all, conduction is best certainly when there are free electrons. Conduction is better when there are free electrons. And it is a solid. So certainly it is better in R than in Q and P. Easy question. Question number 17. A seismic wave has a frequency 5 hertz, speed. Now there is a trick here, so don't fall for that. Since you need all options to be in kilometers, do not change the speed. So you want to find lambda, the wavelength. You know that wave equation says V is equals to F times lambda. Lambda will be V over F. V is 10 kilometers per second divided by F, 5. 10 divided by 5, 2 kilometers. Option is C. Question number 18. Sound waves will diffract through a gap which is passing the edge of a barrier. Which size of the wavelength gives the most diffraction? First of all, before you choose this answer, the diffraction is proportional to wavelength. Number two, diffraction is inversely proportional to gap size, but diffraction will be maximum if gap size is similar to wavelength. Gap size should be similar to wavelength. So small wavelength, no. Since you need most diffraction, so certainly there should be more wavelength. So A and B both are wrong options. Now, wavelength similar to gap, similar to gap. Now, passing the edge of the barrier should have what? Small wavelength or large wavelength? Larger the wavelength, more the diffraction. Option is D. Question number 19. A boy is having his eyes tested. A letter is printed on the card placed over his head. He sees the card in the plane mirror. Plane mirror, before you choose any option, it has 5 characteristics. How many characteristics? 5. It should be upright. It should be same size. It should be same distance. It should be virtual. And eventually it is laterally inverted. Laterally inverted mean the letter R, if it is like this, the mirror will be like this. Which option is laterally inverted? Option B. Question number 20. The ray of a light is refracted as it enters air from glass. It is going from glass to air. Angle of incidence and refraction, they both must be from normal. The incidence angle from the normal will be 90 minus 60. I is 30 degrees. Angle of refraction is already with the normal. Whenever light goes from glass to air, we say N is sine R divided by sine I, because it is going from dense medium to air. Sine of 50 degrees over sine of 30 degrees. You use the calculator and get the answer. I think it is 2 point. No, you need speed. So first it gives you refractive index, which is approximately 1.5. Now first you found the refractive index. After calculating the refractive index, you will look for the formula of speed. You all know, my dear, that refractive index is speed of light in air over speed of light in glass. Speed of light in glass will be, speed of light in air is known. You should memorize 3.8 into 10 power 8, 3.0 into 10 power 8. So V in glass will be 3 into 10 power 8 over N is 1.5. You substitute, the answer comes 2.0 into 10 power 8. The option is A. So what you have to do this question in 2 steps. Step 1 was to calculate the refractive index. Step 2 was to find the speed. There was a trick in the question. The angle of incidence was not with the normal. We subtracted from the 90 degrees and then you calculate the angle from the normal. Then you substitute the formula to get the N. Once you got the N, you will use another equation of N in terms of speed of light. It got you the speed of light in glass. You got it. Question number 21. A converging lens is actually the convex lens, is used as a magnifying glass. Magnifying glass, you know many informations. 2 of them I can tell you. It's a virtual image, okay, and it is upright image. Which statement about this is correct? The image is further away from the lens than there is an object, my dear. So it is, first of all, correct option. Why? Because whenever you get the image through a magnifying glass, for example, this is the focal length. So here is the object. You all know whenever you want to make the image, you go this way, and then you go this way. You extend these rays back. When you extend these rays back, now look, where is the position of the image? This image I'm making with a blue color. This is the object, this is the image. So distance of image is more from the lens as compared to object. Option is A. They're saying image is inverted. No. Magnifying glass is upright. Is real? No. It is virtual. Object must be placed at focus? No. It should be between focus and lens. So all other options are wrong. Option B, A is right. A. Question number 22. Which colors visible are in correct order of increasing wavelength? Don't write. What's the correct order? ROYGBIV. You want to look from whatever, this is the order. Wrong answer. Okay, so increasing wavelength is up. Up is increasing wavelength. So you want in increasing wavelength. Red first, no. Orange, then green, no. Indigo, then green, then red. Correct. Increasing wavelength is towards red, not towards violet. So correct option is C. Wavelength increases towards red. Wavelength decreases towards violet. Option is C. Question number 23. The diagram shows 3 types of electromagnetic radiation listed in particular order. The electromagnetic radiation is traveling in vacuum. Which quantity increase in the magnitude from left to right? Don't worry, I will tell you. Real Madrid is very ugly, except goalkeeper. Radio, micro, infrared, visible, ultraviolet. Radio, micro, infrared, visible, ultraviolet, X-rays, gamma rays. Again, same thing. So they want to ask you micro, infra, X. Micro, infra, X. So as you go down, frequency increases. As you go down, frequency increases. As you go up, wavelength increases. So which quantities increase? As I just told you, frequency increases. Answer is B. Question number 24. Which row gives the typical values of speed of sound at room temperature? We already have a bit idea. Typical speed in air, 330 to 340. In water, 1,500. In iron, iron is metals, more than 3,000. More than or equals to 3,000. So air, 340. Water, 1,500. Iron, 5,100. Option is A. Question number 25. Magnets. 2 small compasses are placed close to a strong bar magnet. In which directions do the compass needles point? Ants. For magnets, please learn. For magnets, learn a mnemonic. I made it ants. A-N-T-S. Magnetic field or the compass, A-N. It will be away from north. T-S. It will be towards south. Away from north. Is this away from north? Is this away from north? Yes. Is this towards south? Yes. Option is B. The wrong ones I just crossed. Ants, A-N-T-S, A-N, away from north, T-S, towards south. Correct option, B. Question number 26. Students are asked for a statement about magnetic field. 3 statements are here. A magnetic field is described as the region where a stationary electric charge experiences a force. No. Electric charge can experience a force, but it should be moving electric charge. It can experience force in magnetic field. Option 1 is wrong. Anything with 1 you can cross. It's wrong answer. Now, 2. Direction of magnetic field at any point is direction of force on a south pole. No. Direction of magnetic field is actually direction of force on a north pole. 2 is also wrong. So if 1, 2 are wrong, so it means 3 is only the right option. Let's read what is 3. The relative strength of magnetic field is shown by the spacing between the lines. Yes, if the lines are closer, the magnetic field will be stronger. If the lines are further apart, the magnetic field line will be weaker. The answer is D. Question number 27. A student rubs the plastic rod with the cloth. Rod becomes electrically charged. So rod is charged and attracted by negative. So if anything is attracted by negative, so it has to be positive. And rod is positive. Anything can be only positive if lost electrons. Since it is attracted by negative, so it is positive. Positive because it lost electrons. Option is D. Question number 28. Which circuit shows directions of conventional current? Stop here. Conventional current always starts from positive and goes towards negative. Then electrons. Electrons move from negative and they go towards positive. So conventional current, I, from positive. Longer line of a battery is positive. So shorter line of a battery is negative. Is conventional current going this way? Yes. Are electrons going that way? No. Option A is wrong. Look at option B. Is conventional going from positive? Yes. Are electrons going from negative? Yes. Option B is correct option. Question number 29. A cell has EMF of 1.5 volt. Underline this and give a symbol V. The voltage, EMF, or potential difference, their symbol is V. How much energy, underline energy, symbol is E, question mark. It drives this charge, charge is Q, around the circuit. EMF or potential difference, both are defined as the EMF or potential difference V. They are defined by an equation. Equation says the voltage is amount of energy per unit charge. So V is equals to E over Q. Since we need E, hide E, you will be left with E is V multiplied by Q. Sir. V is 1.5, Q is 6. Answer is 59. Question number 30. Question number 30. A metal resistance wire of length L cross section area A has a resistance R. What is the resistance of a metal wire with the same material that has 2L the length? Area is half. We will make individual tables. Resistance is directly proportional to length. So length versus resistance. If length is multiplied by 2, resistance is also multiplied by 2. Now, the cross-section area, I will use blue color. Resistance is inversely proportional to area. I will also make a table here, area with resistance. If area is divided by 2, resistance will be multiplied by 2. Now over here, due to length, resistance is multiplied by 2. Due to area, resistance is also multiplied by 2. So overall, the resistance will be multiplied by 2 and multiplied by 2. Answer is 4R. Option is D. If the length is times 2, resistance is also times 2. If the area is divided by 2, since inversely proportional, the resistance will be divided by, multiplied by 2. So multiply by 2 because of length, multiply by 2 because of area. Overall resistance will be multiplied by 4. Option is D. Question number 31. Diagram shows 2 circuits. Each relay is normally open when there is no current. Which environmental condition will cause the LED, light emitting diode, in circuit 1 and in 2 to emit? Emit means the diode must be on. Let's go one by one for each of them. If this diode you want to be on, this switch should be on. This switch to be on, electromagnet should be very strong. For electromagnet to be strong, the voltage share should be high. For high voltage share, this LDR, the resistance should be high. High resistance of LDR is only in dark. LDR, again, for diode to be on, electromagnet should be very strong. For electromagnet to be very strong, the voltage share should be high. High voltage share is only obtained because it is proportional to resistance. More resistance of LDR is only possible if it is in dark. Okay, so first of all, the dark, the light intensity, dark mean low light. Dark mean low light. Now go here. Blue color I will use. For LED to be on, switch must be closed. Switch to be closed, electromagnet should be very strong. For electromagnet to be very strong, this voltage share should be high. If this voltage is high, the other voltage share should be, sorry. So other, if the lower, yani this V1 is high, so this V2 should be lower. V2 lower means resistance of thermistor should be less. Thermistor resistance can only be less if temperature is high at hot conditions. So at hot condition, thermistor resistance will be less, voltage will be less. So down, V1 will be more voltage will cause electromagnet to be very strong. Strong electromagnet will close the switch. When switch is closed, LED will be on. So our answer should be hot and dark. Dark means less light. Hot means high temperature. Option B. B. Question number 32. Your favorite transformer. 100% transformer efficient. Input power should be equals to output power. Primary power is equals to secondary. Power is VI. So VP IP is equals to VS IS. First of all, look for this option. Okay, here and here. A and D. So B and C are wrong. Now every transformer, the ratios of turns VP over VN, actually ratios of turns VP over NP is equals to VS over NS. Which option? A. Transformer, the number of turns ratio to the voltage is same. Also, the input power VP IP should be equals to VS IS. The right combination of the options is A. Question number 33, nuclear physics. Neutral atom. You too know in chemistry, any atom is neutral if number of positive and number of negative are equal. If 2 protons, there should be 2 electrons. If 3 protons, there should be 3 electrons. Here, 2 electrons, 2 protons. Yes, correct. Here, 1 electron, 2 protons. Wrong. 1 electron, 2 protons. Wrong. 2 electrons, 1 proton. Wrong. Neutral atom has equal number of electrons as well as protons. Option A. Question number 34. What is nuclear fission? Fission is splitting of a large nucleus. There is a large nucleus, a neutron hits, it splits into smaller nuclei, and a lot of energy is released. This process is called nuclear fission. So, question 34. Splitting of a large nucleus to create the smaller nuclei. Option 1 is saying merging. Merging is joining, which is fusion. Electrons removed, ionization. Star generates energy is fusion. I'm just telling you, this is called ionization. Fission is splitting of a large nucleus into smaller nuclei. It is called fission. Question number 35. Diagram represents the paths of the 3 types of ionizing radiation, X, Y, Z. And which statement about ionizing radiation is correct? I don't want to read any option. I will train you in a good way. The one which is not bending should be gamma rays. Then tell me others. X. Beta radiation have minimum mass. Please pay attention. The beta are very light, least mass. So they bend more. They bend the most in magnetic and electric field. So this one is what? Alpha. So which statement about the ionizing radiation is correct? Option A, they are saying that X is positively charged. As you know, I can tell you, X is beta negative. Gamma is neutral. Alpha, we decided Z, it is positive. Option A is wrong option. Y is negative. No. Y is gamma, it is a neutral. Option C, Z is most strongly ionization. Since Z is alpha, and yes, alpha is most highly ionizing radiation. X has smaller mass than Y. Y is massless. Y is massless, doesn't have mass. But X is beta, it has a mass. It is also wrong option. Correct option is C, my dear. Question number 36. Which row correctly matches 3 radioactive sources to their uses? Emits alpha particles and has long half-life. Now, where do we use alpha and for long? Mostly smoke alarms. Monitoring the thickness, we use beta particles. Yes. Now emits beta. Emits beta. So beta is used to control the thickness. That's it. So it means the gamma is used as a tracers to detect cancer. Cancer treatment and diagnosis, we use gamma radiation. Good uses. Correct option is C. Now we will enter the next question, number 37. Why are some radioactive sources stored in the boxes made from lead? Lead can stop all types of radiations, whether alpha, beta, and gamma, so hence it is safe to store there. Lead absorbs the emission from the radioactive sources. Absorbs means stops. Option A. Question number 3. Now we will enter the space physics. Average distance from Earth to Sun is this. You have the distance. What is the orbital speed? You need to assume this. Here is Sun. Here is the orbit for the Earth. Sun, Earth. To find orbital speed, we need 2 pi orbital radius divided by time. Orbital radius is the average distance, which is 1.5 into 10 power 11. This question is a bit tricky since we need kilometers per day. So distance should not be in meters. Meters must be changed into kilometers. To change meter into kilometer, we divide by 1,000. When you divide by 1,000, so this distance comes to be 1.5 into 10 power 8 kilometers. Orbital period of Earth in days is 365 days. You substitute the values in that equation. This equation gives you orbital speed. 2 pi orbital radius is 1.5 into 10 power 8 kilometers. Divided by, in days, it is 365. You divide that. 2.6 into 10 power 6. Option is C. It was a good question. So we changed the meters into kilometer by dividing by 1,000. Days we kept 365. The distance between Sun and Earth is considered to be orbital radius. Orbital velocity or speed is 2 pi r over orbital period. 2 pi r over period is 365 days. You divided them, you got the answer 2.6 into 10 power 6 kilometers per day. Option is C. Question number 39. In which order are the objects listed during the life cycle of a star? Protostar, red giant, supernova, stable. This should be here. Then it will be right. Protostar, stable star, red giant, supernova. Correct. Stable. Okay. So if you write for all of them, I can tell you the correct order is 1, 2, 3, 4. This should be the correct order. 1, 2, 3, 4. So only correct order is, I'm just naming, if protostar is 1, stable star is 2. Actually, before protostar, there is nebula. There is a nebula, then protostar, then stable star, then red giant, then supernova. And supernova explodes into a neutron star and the black hole along with a dwarf. What is the distance traveled by light in 1 year? This is actually called 1 light year. 1 light year you need to memorize, my dear. That was 9.5 into 10 power 15. No, 10 power 18. No, light year. No. 10 power 15 meters. Yeah. Option is, in case if you forget it, in case. So you know the distance is speed multiplied by time. Speed of light is 3 into 10 power 8. Year. Year is 365 days. Each day is 24 hours. Each hour is 3,600. So answer will be 9.5 10 power 15 meters. In case if you forget it. I hope you understood this paper. See you for the next paper. Thank you.